Okay, welcome back. We're going to wind up this initial part of the game development here until so we have a working game. And this is for Hyperactive Studios. And my name is Nate Nessler. And continue on. This is going to be video 9. And we're going to have our random. We need to import random. We need to import the player class we developed already. We need to import the troll class that we developed already. The ogre class needs to be imported. Dragon class. And let's not forget about our wonderful pissed off bunny. It's the major boss character in the game. It's a bunny. I just had to. Alright, so class, game here, open close parentheses, colon here. For defining a new class called game. We saw this at the very beginning in the first video when we did game.run. Here we are. So we're now defining that class. And this essentially is the game engine, more or less, for a text-based game. So this is fairly simple for this whole thing, thankfully. We start getting into like the graphic sides of game development. It gets a lot more complicated. 2D games aren't too bad. 3D games are extremely complicated. Extremely complicated. I got a whole bunch of videos on that, so if you're interested in seeing that, I got it. Matter of fact, some of the only videos around on the subject matter. So here we go. We have def here, underscore init, underscore open parentheses self, close parentheses colon. So we're not doing inheritance here. We're just finding our own class from the ground up here. Self.playerCharacter equals player class dot player, open close parentheses. So we're getting the player class from the player class file, and we're assigning it over to our player character. So it now becomes a game object. This becomes a object as a variable, becomes a property of game, is an object of the player class. So this player character is going to have all the properties and methods that comes from the player class, and we can do everything that we defined in the player class. Makes life a lot nicer. Self.location, this is just in a list here, and it's just listing all the different locations. Now we could have additional features on here. We could actually make a location class where maybe it has certain features and the dealing with the class, maybe cold or heat affects you or some way. You could do stuff like that. I mean, maybe wind affects you in certain ways or whatnot, and you could actually define that on the locations and define how this manipulates everything. We have going into enchanted forests of elves. We have a dewy meadow, fiery lands of volcanoes and shores, across frozen seas of Evast. I don't know. You find yourself in a vast underground cave network. Ooh. Cross a fog-covered bog, and then you come to a small village. Why not? I guess we should probably have stuff like castles in there too, but whatever. Self.score, so we have a score for the game as it goes along. And this is a player score. And then we have self.enemies equals, and then this is going to list all the enemies. So we have troll class.troll, so we get a troll object. Ogre class.ogre, get the ogre object. Dragon class.dragon, get the dragon object. And it doesn't end there. We also have our pissed off bunny. Can't forget about the pissed off bunny. So that's going to be the pissed off bunny class. And it's going to be dot pissed off bunny. Close parentheses. And then we end our end of our list right here. Okay, so if you need to, you can pause the video, type this up or whatever, but I'm going to go down to the next line. Okay, and then we're going to go self.enemy selected equals 0, and so now we have 0 enemies for starting. Enemy selected. Player attack, so we're going to define the player method. So this starts up our game, basically. This is the init function here. Starts our game, more or less. Or sets it up anyways. It sets it up, it doesn't start it. Let's be a little more clear in that regard. Player attack here, we're going to pass in ourself again. And then it's going to be self player character dot determine damage, open close parentheses. And we're going to decide how much damage the player takes, right? Self enemies, self.enemy select dot life minus equals self.player character dot damage. Probably go, what? Yeah, okay, so we have the enemies selected here and enemy's life, and the player character can do damage to that enemy. So based on whatever the enemy that is currently selected, we are actually damaging it. So this is the damage strength of the player character here, and we're saying minus equal to the enemy's life. So this is going to deduct from the enemy's life right here. And so out of all the enemies, we're selecting this particular enemy, and it's based on whatever the selected enemy is. So, you know, it's going to be some number in the range of number of enemies within the enemies list, and this way this enemy is selected, and then we are deducting from its life. It's gotten attacked by the player. Player is taking damage, and then if the player survives the damage or whatnot, well, not even if the player survives the damage, the player takes damage and it gives damage to the enemy. All right, so you have the potential of the player getting killed and the enemy getting killed at the same time. It happens. So if self.playerCharacter.damage equals 0. So if the player character has not has no damage ability on it, so the player goes for a strike but misses. So if the player is going to basically wield 0 hit damage, then he missed, straight up missed. Else, then the player apparently has definitely done some damage. So we have to determine that. So the player attacks and does, and we're converting it to a string here because it's a number, and then we find the player character's damage. So how much player damage does the player character do? It's going to be an integer, and we're going to convert that to a string so we can concatenate it with the rest of this sentence, and we're going to say damage period. So we're basically going to saying the player attacks and does however much damage he does, and then we say damage period. And then self plus equals 10 for score. So every time the player damages an enemy, he gets plus 10s for a score. And then you say print the self.enemies, self-selected enemy name. So basically we're getting the name of the enemy that we are attacking, we're fighting with. That's the selected enemy. So we're getting out of the list of enemies, we're getting the enemy that we are fighting, which is the selected enemy selected, and we're getting its name. So this way we can say and what the name of the enemy is. Now has, and then we say convert it to string, and we're going to say self.enemies, and then we're going to do self.enemy selected, so that we're talking about the enemy we're fighting, dot life, so we can find how much life that enemy has. Close parentheses for that string and continue on over. We're going to concatenate that with life, and we're going to say how much life is left, period, to end that sentence. Okay, cool. And so that's going to end up having to say, you know, the enemy has this much life or whatever. You know, like for instance, the ogre now has, you know, 27 life left. There you go. So basically that's what it's going to end up saying with doing that. So enemy attack, we have function. So we did a player attack, but we need to handle an enemy attack, right? Yeah, it's kind of important. So here we determine how much damage the player can do. Sorry, the player is not taking damage. The player is basically just determining how much damage the player can do in a strike. So you know you don't do the same damage each time. Here in this case, the enemy attacks and the player is going to take damage instead of the enemy taking damage. So we have self.enemies, self.enemy selected. Depending on which enemy we're fighting, gets that particular enemy out of the list of enemies and determine the amount of damage that the enemy is going to do. Then we have self.playerCharacter.life minus equals self.enemies, self.enemy selected. So again, we're getting that particular enemy we're fighting. It's the same code over and over again. And we're going to get how much damage that character can do, and we're going to subtract that damage from our life. So we lose some life based on that damage that we just took. So if the enemy did 0 damage, then the enemy missed. So we have to say print the blank, print the self enemy selected, basically the enemy we're fighting, and its name. So for instance, maybe it's a troll, right? So the troll goes for a strike but misses. So you know they did no damage for that enemy. And then here we're going to print plus. Here again we're referring back to the enemy and its name. And this is where the enemy did do damage, and it's attacks and does, and then we need to find out how much damage it does. So of course we have to convert this to a string. So we do a str on it, and we're saying again self.enemy selected, self.enemy selected. Again, this is pointing to the enemy we're fighting right here, and then how much damage that enemy did. This is how much damage the enemy did, and we're converting that to a string, so it can be concatenated with the rest of the sentence. And then in quotes here, we're going to say damage, period, and that ends the quotes. Awesomeness. And then print here, the player now has, and str here, self.playerCharacterLife. So we're getting how much life the player now has, and plus life left. Period in quotes. Alright, so that does an enemy attack, and it tells us how much we have left for the player character. Alright, and then when we do a battle, we need to actually define how a battle works. So we're going to say print a great battle begins as we're getting ready to fight some enemy. So this is how we get enemy selected, basically. You're like, oh, the enemy selected you saw it earlier. Well, this is how we set the enemy that's going to be who we're going to battle. So self.enemySelected equals random.randint 0, len, open parentheses, self.enemies, close parentheses, -1, close parentheses, right? Because we're going 0 to 1 less than the number of enemies in our enemies list. And so this is going to grab one enemy out of the enemies list. And it's going to assign that enemy value, for which enemy we're talking about, to enemy selected. And then self.enemies here, self.enemySelected.determine life. And it's going to determine how much life the enemy has based on the enemy that is selected from the list of enemies. So while self.playerCharacter.life is greater than 0, so while the player is still alive, and enemy selected.life is greater than 0, and the enemy is still alive, we have to fight. So self-player attack, so the player gets to attack first, and then the enemy. And it doesn't matter which one attacks first, really, honestly, because we're doing this in a loop, and we don't test to see if one of them has died until after they've both attacked. So it just keeps looping until someone dies. So either the player dies or the enemy dies. Whichever one dies first, we keep battling until that happens. Okay, and then over here, I'm going to start another function. So def travel to location, and we're going to print self location random int so that we select a particular location out of the list of locations, and we're going to do the number of locations -1, so that way we do 0 to 1 less than the number of locations, so that way we don't go out of bounds with our list, right? And then we're going to close that as a way of selecting which location out of the location list. So this location list has all the locations in it, and so we're selecting an individual location out of that list of locations randomly. So that's how that works, and we're just displaying it. Login, we're later going to create a login method so the player can log into their account. So yeah, we're going to have game accounts here. Already written this up. We're going to add it. And then read a file. We need to be able to read the player characters, the game account file, so we can see how much score they had, their player history, blah, 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 whatever you want. Verify login. We have to have some way of verifying that the login is legit and that someone's not trying to break into an account or someone else's game or something like that. Write file. We need to save out a game file for that player, basically. Over. When is the game over? Okay, well, we need a function for handling when the game is over. A method, if you will. So the game over, your score was, and then we need to tell the player what their score was and how much points they acquired. So there you go. And then we tell them thanks for playing. And then run. Run is actually going to make the game run. So the game is going to continue to loop until the game is over. So print game loop that makes the game run. Now, honestly, I don't really need this in here, and I can remove that. I just put it in there so that, for the intent purposes of teaching. In the real world, you would not leave that in there. I just did that purely to make it easy to follow that this is the game loop. Now, granted, I don't have to do this. I could just, put a pound sign here like that. And then we get a comment to that in that regard. Okay. And I can save that. That's fine. And then we have while self.playerCharacter.getLife, open close parentheses, greater than 0, self.playerCharacter.upkeep, open close parentheses, self.travel to location, open close parentheses, and self.battle, open close parentheses. So how does this mean? It means while the player is still alive, right? Because we're going to get the player character's life, and if the life is greater than 0, then the player is still alive. Then we're going to say self.playerCharacter.upkeep. We need to determine, what all's going on with our player here. Do they need to switch up potions? Do they need to health? What do we need to do here? Do we need to toss away a shield and maybe craft one? Or, we could do stuff like that. We can do that in our upkeep. So we need to do a player upkeep before we start in our game loop. And then we need to travel to a location. So we're going on a quest, on an adventure. And then we're going to battle. We're going to battle some character, some creature that we encounter out in the world here. And then after the player dies, because this is going to keep going until the player dies, okay? Then once the player dies, then we're going to write out the file for the player's file, for what their score was and all that stuff. And then we're going to show the game over message and let the player know what their score was and all that stuff. But we save out their game progress before we even display the game is over. And that essentially is the game. So when we run this is going to be no user input, meaning that no one's going to type in any input. You can change it to do that, where people could put input. We're probably going to do that, especially with the crafting. We don't have to. We can automate the crafting too. It's really up to you whatever you want to do. But if I run this now, bam. Take health potions, switch weapons, craft potions, etc. You come to a small village. A great battle begins. The player deals 79 amount of damage. The player attacks and does 79 damage. The Pissed Off Bunny now has 96 life left. Oh no, we're fighting Pissed Off Bunny. The Pissed Off Bunny attacks and does 50 damage. The player now has 50 life left. The player does 12 damage, deals 12 amount of that damage. I really should change this, and that's just a little cleaner than that. The player attacks and does 12 damage. Pissed Off Bunny now has 84 life left. This is really not going well. Pissed Off Bunny attacks and does 124 damage. We're dead. The player now has negative 74 life left. Yeah, we're dead. Saving your game. Game over. Your score was 20 points. Thanks for playing. We only got to attack 2 times before we got killed. So hopefully you don't encounter the Pissed Off Bunny, because if you do, you're dead, basically. I mean, you could win. It's just odds aren't in your favor. So let's run another game simulation here. Take health potions, switch weapons, craft potions, etc. You have entered the frozen slopes of the Ice Everglades. Great battle begins. The player deals 45 damage amount of damage, whatever. The player attacks and does 45 damage. The ogre now has negative 17 life left. The ogre is now freaking dead. The ogre attacks and does 9 damage. The player now has 91 life left. Take health potions, switch weapons, craft weapons, etc. Come to a small village. A great battle begins. Alright. See, we were in Everglades, and now we're at a small village. Player deals 36 amount of damage. Player attacks and does 36 damage. Dragon now has 33 life left. Dragon attacks and does 50 damage. Ouch. The player now has 41 life left. Player turns around and deals 49 damage back to the dragon. Player now attacks for 49 damage. The dragon now has negative 16 life. The dragon's dead. Dragon attacks and does 14 damage. The player now has 27 life left. Take health potions, switch weapons, craft potions, etc. You have entered the frozen slopes of the Ice Everglades. I guess we're going back to the Ice Everglades. We didn't like the small town. Great battle begins. Player deals 85 damage. Wow, that's a lot. Player does 85 damage. Troll now has negative 17 and negative 75 life left. Troll attacks and does 5 damage. Player now has 22 life left. Take health potions, switch weapons, craft potions, etc. You sail across the frozen seas of Avast. A great battle begins. The player deals 69 damage. Player attacks and does 69 damage. The Pissed Off Bunny now has 269 life. Oh, we're dead. The Pissed Off Bunny attacks and does 99 damage. The player now has negative 77 life left. Saving your game, and your game total score was 50 points. Thanks for playing. So there we go. Full game simulation. Of course, you could set it up to where the player could maybe hit different numbers, and then you could randomize based off of those numbers what their move was, and then maybe it sets it off into different choices of probability of what the player could do for damage or whatever. And you could add more interactivity to it. In a real game, you want to add more interactivity than just a total simulation like this. The simulation shows that the game is playing without having to do input interaction and makes the gameplay testing faster. Because then you can just quickly iterate through it and find any errors, and then you can add in interaction later. It's kind of cool. It's to each their own for how they want to develop the game, but this works, and this was the last video for getting the initial game set up and running and working. And then we can add a la carte the additional features to these different parts, and not just pure message being outputted, but actual real code that actually makes it do saving a game, logging in, blah blah blah, etc., etc. Crafting, for instance, really actually do the crafting, really actually switch weapons, really actually create potions and apply them, etc. All right, but with that, my name is Nate Nessler, and this is for Hyperactive Studios. Thank you very much.